Okay, good morning, everybody, and welcome to our second day of this staff week. I hope yesterday was fruitful for you and also that you enjoyed the visit to our town. It is a pleasure for me to introduce our first speaker, Simone Gozzano, professor at our Department of Human Studies. His main research and teaching field is logic and philosophy of science, and one of his main interests is examining real-life situations that involve ethical dilemmas, also related to artificial intelligence. Now I leave the floor to Simone Gozzano.
Thank you. Thank you. Oh, you're already an applause. This is a white check for me. That's cool. How can I put in the presentation mode this stuff? Must be something like... no, it's all right. I didn't like to scroll it. But anyway, that's all right. Okay, thanks a lot. As you may know, I'm a philosopher. Fausto already said that. So when the floor is on a philosopher, situation gets very complicated in a way, because you never know when it goes. As I been told that you are interested in artificial intelligence, and artificial intelligence is the main topic of this week, I will try to explore some paths that have been, in a way, set by the Nobel laureate Hinton a few days ago. You may know that the Nobel Prize in Physics has been awarded to Hinton with another guy. And Geoffrey Hinton was the father of so-called machine learning and backbord propagation. And recently, he quitted from the Google DeepThink team, or I can't remember the name really, because of the existential potential risk that AI may engender to human species, the humankind. He thinks that, as a matter of fact, sooner or later, AI will become more intelligent than us, and it's quite difficult to consider a superintelligence that is governed by a less intelligent creature. So he thinks that sooner or later, this superintelligence will at least patronize us and then dominate us. And so we may ask whether this is a serious threat or not, or what can we do about this threat. And this is something I want to reflect on with you. One of the solutions that Hinton proposes is to imagine machines to be benevolent. That is, we have to program them to be benevolent toward us. But, it seems like a very difficult task to program benevolence. What does it mean? Sometimes we do not even know whether our next fellow is a benevolent person or not. So it's very difficult to judge someone as being benevolent or not. And you may imagine how it's difficult to program something to be benevolent in this sense. So we may ask, is this fear well-founded? Is this a serious threat? The first question that I wish to ask you, the first question I wish to pose is, what is our home? That is where human beings find their own home. And surely there is a sense in which our home is the natural world. And we interact with this natural world not only by behavior and making gestures and the like, but mainly by adopting and using our intelligence, which means by expressing ourselves through oral language. That is the achievement of human beings from controlling fire on has been possible through the use of a more or less sophisticated system of symbols. Because with the symbols, you do not need to face yourself directly with, a dangerous tiger, but you can just say, there is a dangerous tiger there while in a safe position, while in a safe situation. So you can, so to say, toy with the world without risking anything from the world. But at the same time, and this is the part called the semantics, but at the same time, through words and sentences and propositions, we can do things in the world. There is a sense in which you can do things just with words. For instance, making a promise. You can do a promise just by saying, I promise. There is no other way of making a promise. But there is also a sense in which we can do things in the world by commanding or describing and then acting. But it is just the words that allow us to understand how to behave and how to act into the world. Now, we know that there is a sense in which machines interact with us through words. Now we are pretty used to large language models such as ChatGPT or the like. And the basic idea of using words and being satisfied by the way this machine uses words was set by Alan Turing, the famous mathematician and computer scientist, even if he invented the computer science, so he wouldn't call himself a computer scientist, that set what is called the imitation game. I mean, I guess you are familiar with the imitation game, are you? Basically, the idea of Turing, I mean, imagine you created this game in 1935 in the first version, then 54, the second publication, was something like that. Imagine you're being in a chat. You know, you're chatting with someone, and so you can just see the screen, the chat, the interaction. Now, is the person on the other side intelligent? Suppose you say, yes, that's a clever person on the other side of the chat. Well, if the person on the other side is not that person, but is a machine, then is an intelligent machine. The very clever idea of Turing was this. Instead of having a definition like the typical, mathematical definition, a function f such that blah, 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 or something is a cow if and only if blah, 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 it gave us what is called an operational definition. That is something that has to be done. And it's not a matter of creating something like a circular way of defining that I am intelligent, I define you being intelligent, so you are intelligent. Because that's not a dangerous circle, that's a virtuous circle. Because intelligence is the good interaction between us, no more than that. There is no hidden secrets that establish who is intelligent. By having this definition of intelligence, we create a sort of ambiguity because there is a sense in which it is independent on whether the sentences has been said by human beings or machines to judge the sentences to be intelligent. So we are, so to say, indifferent with respect to the intelligence of the sentences. But we know that machines are programmed through their syntax, that is the rules that put together words and pieces of words, so you got bored already. The rules that put together all the chunks of the language. So it seems that the syntax of the machine is in a way enough for the semantics, for the way in which we understand the meanings and we understand each other and judge each other to be intelligent or a right person or the like. Is this okay? I'm going too fast or good? I'm always surprised because it took me a lot of time to understand this stuff. And so I think I'm the dumbest in the room. So we talk to these machines. We think to have a direct grasp on the semantics of what has been said, and we know that there is a sense in which these machines are able to mimic, to pretend to be as intelligent as us, just with a bunch of well-formed formulas or well-established syntax structures. So we may ask, are we having a felicitous conversation? A felicitous conversation is one in which not only the the interaction goes smoothly. But also one in which, once the interaction has been done, there is the possibility to pile up new things, to draw some inferences, to establish new conclusions and the like. That's a felicitous conversation. You know, imagine you're talking to your Paul and say, okay, do you want to have a coffee? Oh yeah, that would be very nice to have a coffee. Okay, let's have a coffee. And they keep staying there. I mean, I told you, let's have a coffee. So it means, let's have a coffee there. No, it just popped down from nothing, the coffee. So that wasn't a felicitous conversation. And this was an idea by this guy called Paul Grice. And we know that there are even ways in which we may let a conversation to fail its felicity condition to give some further meaning. Is Simone a very handsome guy? He's a clever one. You imply subtly that he's not that handsome, but he's clever, something like that. So you are violating one of the rules of conversation, give an adequate response. So to imply something else is not that nice. Anyway, you may have a coffee, but you have to go there. Roger Schank, an artificial intelligence scientist, back in the 80s, I'm an old guy and I know, proposed sort of a program in which this program was able to reply to questions related to so-called toy problems. That is, the toy problems was, let's program a machine to understand whether a person that went to a restaurant, has waited 35 minutes or something, and has got an almost completely burned steak, will give the waiter a nice tip or not. And the program reasoned, what is to have a nice restaurant evening, to have a prompt food, the food should be well cooked, something like that. So he replies, I won't give him a nice tip. So Schank was saying, the computer are understanding. The computer really, because there is not an explicit definition anywhere in the program, but still the program is ready to draw the conclusion that we would draw were we in the condition imagined or described by the scene. To this condition, to this situation, a number of scholars, in those cases it was John Searle, the philosopher John Searle, but basically also the linguist Noam Chomsky is arguing along the same lines against the large language models. Both they were stressing that actually machines didn't really understand anything. They're just computing syntax structures, just moving chunks of language from one side to the other. And once this has been done, this is okay, but they're not really grasping, they're not really having a direct contact. With which kind of contact they were imagining? Well, when I started to say what is our home, what's the place we are in? Well, it's the kind of contact that we feel we have when we say, give me the bottle and I do something like that. That is the kind of contact that we imagined ourselves to be raised in, not just as persons, but as a species. It's 200,000 years that we have been raised and interacting in the world more or less like that. And we think that the machines, just by juxtaposing properly pieces of syntax, they are not doing that kind of interaction. They are just simulating that kind of interaction. So it seems that there are, in a way, two forms of relation, or I call this causal relation. I cause this to be raised from the table, and I cause it to be back on the table again. One, which is the real one, the one that is done through natural history and the like, and real computation, the other, real interaction. And the other one that is done just by a simulated kind of interaction. What should I do this way? But then we may ask ourselves, what happens when we want, in a way or another, to be in the digital world? That is, what happens when we interact deeper and deeper into the digital world? I have a daughter who is working with 3D modeling and virtual reality, so she passes hours with this headset. You know? She's really is in a digital world. She even uses an alarm, so not to stay there for more than 2 hours and a half or 3 hours or something. I throw up after 5 minutes when I have this stuff. But we should ask ourselves this, because we are familiar with the concept of an infosphere, which is the whole amount of information, knowledge, interaction procedures and the like that we have uploaded somewhere in the cloud or whatever you want. And the more we go forward, the more the infosphere grows. Actually, I mean, presently, I don't think there are many scientific results that are not digitalized. We write papers, we draw things that are then scanned and then uploaded. Project by the architectural project are all made with computers, and perhaps the archaeologists, you know, they dig the terrain. We have a colleague here. But then all the objects are digitalized in a way or another. Virtual museums are realized, and so forth and so on. So we are letting this infosphere to grow larger and larger. Now, the question that I was posing a few minutes ago, that is, what is our place in the digital world, is what is our place in the infosphere that we are creating. And it seems that we used to think about native digital, the digital native, I can't remember. But these are not the kids. These are the computers. Because kids still are human beings that we consider to have the proper interaction with the semantics and through semantics with the world. We know they are very smart. We know that, you know, they scroll the pages on a physical magazine thinking that they are like computer screen or the like. That's it. Everything's all right. But still, we attribute to them the very same kind of causal relation to the world that we attribute to ourselves and that we used to attribute to our grandfathers and mothers, grandparents. So the digital world is inhabited by machines, really, and we are the guest of that digital world. So you may guess where I'm going. Is that now what you got, right? So I'm supposed to add 10 minutes or something? You shoot me. Shut up. So some philosopher used to imagine something like that. Or there is a sense in which we can imagine all the physical relations to be computational relations. To give you a very nice image, one of these philosophers called the gravitational law the software of the universe. That is, there is a sense in which all the laws of physics, of chemistry, etc., can be interpreted and frequently are transformed into computational laws. And you know that now that speaking of this year Nobel Awards, the Nobel in Chemistry has been awarded to 3 guys, 2 of which have done a program for discovering the protein fold, how to resolve the problem of protein folding. So they didn't do specifically something, you know, with pipes or stuff in the lab, as the 3rd one did, which was older. But basically they programmed something to do that kind of job. So we can imagine a world in which everything is computational, and imagine to consider in computational terms what we have done into what we do in our physical world. But if pan-computationalism were true, that's the name of the view, then obviously the difference between the proper interaction we have as human beings and the interaction that machines have through programming is lost, because the idea is that everything is a computation. So this difference would be lost completely. So perhaps we should avoid the Scylla of the pan-computationalism. Let's see where the Charybdis is now. Let me skip this one. So we may want to trace again and again this kind of divide between us and the machines, and we are, in a way, doing this, because we are pushing toward what is called machine autonomy. This concept is pretty clear when we discuss, self-driving cars. And we want them to be autonomous. That is, we don't want to have any kind of interaction with them. We want them to be able to drive us from home to office and back, or something like that, right? So the greater their autonomy, obviously the lesser is ours, because they are in charge. So we are basically a suitcase in that car. And this kind of situation may arrive up to the point in where machine take our own decisions. Machine can have what Hinton was suggesting, like a paternalistic attitude toward us, because they know better than us what we should do and we should not do, which is quite of a consequence, I think. Where are we? Okay, well, I'm pretty done. So, before getting to this, let me, in a way, wrap up the picture that I've been trying to give you. If we want to keep with the distinction between the real interaction, the causal interaction, that is the one that we do, and the pseudo-interaction that machines do, which is nothing but data syntax manipulation, then we want to separate the divide between them and us. We should be aware that once we are in the digital world, we actually are the guests, and they are the host. And since we are inflating and increasing this digital world more and more, we are reducing the space in which we are the host and they are the guests. So we are reducing our autonomy, because we are making the world so deeply digital that would definitely be governed and managed by machines and not by us, because they would be too much complicated for us to manage. If we want to keep this divide, then we should deflate, in a way, the digital world. We should imagine safe islands, places, conditions, problems, and so forth that are not digitalized. Because in that case, we were just our own landlord of our own places. As long as the digital gets into that, we are lost in a way. Worst would be to imagine that everything is a computation, because in that case, we would completely be lost, and we may be prevented from accessing our own knowledge. This paper was originated by a conference on the libraries. And we all know that we like digital libraries, and We all like the digitalization. Yesterday we had here a conference in the Human Studies Department on the Boccaccio digitalization of all this work by Boccaccio, etc. This is very nice. But we may be prevented from accessing this stuff for any sort of reason. Because we have been unable to properly save the stuff, we have done some digital damage or something like that. And so the machine says, you know, for future user, I not allow you to get into the system anymore. That's advertising, for instance. Yes, it's advertising. Damn, I hate them. Now, the future of machines, as I have on the slide, the future of machines is our future. There is no distance between them and us, in a way, because we are deeply intertwined with them. So we should be quite careful in imagining the future of machine, because we are imagining our future. And the compatibility between these two futures rests on this, I think. We are pretty used to a world that is unstable, fuzzy, in need of continuous adjustments. Yeah, I mean, we started 9:30 sharp, and I'm going to finish 10 sharp, and then we have question and answer and the like. But we know that, you know, after a nice glass of Montepulciano, we can start 9:05, all right, give me a break and the like. And we are used to that, because we should think to ourselves in the very past. I mean, we were used to the fact that, oh no, I don't know how's the weather tomorrow, and we'll see, and whether there will be food on my street, and there will be an animal on my road, and whether I will be home this evening safe or not. That was part of our life. But machines, they are trained and they are done not to have a shaky future, not to have a fuzzy future. They are trained and arranged and set to have quite a stable future, quite a foreseeable future. So these two natural tendencies are quite different. And so in imagining our future and the future of machine, we should be very well aware of the fact that we are intrinsically different from this point of view. And so we should be quite careful in our own decision. Thank you for your attention. It really says so.
Thank you for your speech and for your interesting point of view on this matter. If you have any question. Okay.
Hello, Piotr Kazimierczak, I'm from Poland. Thank you for this amazing talk. I was struck by your example of autonomous car. When we come to think about it, we give up some of our decision-making process to the machines already, right? So if we decide to have a go in an autonomous car, then actually the machine decides for us, for this 20 minutes drive, let's say. And it's already happening, isn't it? So my question, the first question is, how much of this do you think, like in percent rate of our own world, have we given up already to the machine, to this digital world? This is the first question. The second question, would you feel comfortable to have a ride in an autonomous car by yourself? Would you feel comfortable to have a ride in fully autonomous car?
The answer is I don't know to both questions in a way, but let me expand them a little bit. I don't know how much we have already delegated to machines. And I'm not sort of a ludist that is, no machines anymore or something like that. For instance, there are these programs that help doctors to establish a diagnosis because they run, they get fed with all the analysis and the real summary of the symptoms, and then the machine runs a probabilistic program that tells, the highest probability is this sickness, the less is the other one, blah, blah, blah. And I think that this is quite an interesting kind of program and quite an interesting kind of stuff to have. Surely, what we are losing in that case is what is called the clinical eye. The ability of the old-fashioned doctor just to tell you, say, oh, no, this should be an infection of the liver or something like that, because you look like one of those. No? Now, this is not a peroration of the good old days, but is stressing that when artificial intelligence scholars or computer scientists, they keep saying that the man in the loop, or the person in the loop, to be gender neutral, that role has to be magnified more and more because it has to be expanded more. And I think in particular of autonomous weapons in this case, so to make things even cruel, where because of the shortest time of decision, human beings tend to delegate much more to the machine because I'm not really, okay, go, decide yourself. And the machine, in the way in which the machine has been set, is predetermined. So that part wasn't enough a person in the loop because from the report that I have seen, typically these autonomous weapons tend to exaggerate on the side of the protection of their own army, so to kill much more civilians than expected. So this is a first very important part, I think. I don't know how much presently, how much the artificial intelligence is. But for instance, you may remember when PowerPoint was first delivered. Now we seem to think PowerPointly. When we want to arrange a talk, we tend to organize it into chunks, well-divided chunks and the like. And no, the idea of having a talk with a chalkboard and the like, there is no more. And I don't think that, those guys from the 20s, 30s, and 40s that in the last century, they basically said our science, they were not doing good. I mean, it was possible to have fantastic. There are even discussions between mathematicians that stress that now many more theorems which are proven in mathematics are proved thanks to the computer. So mathematicians start to think to problems in terms of how can a machine help me improving this, instead of pushing their own creativity. So there is a subtle, continuous delegation. That's what I just point out. Would I feel comfortable in an autonomous car? I would love to have one. I live in Rome, I work here, so I commute. It's now 25 years that I commute from Rome to l'Aquila, so I would love to read. But sometimes I call it a bus, and I drive, and there is a guy called a driver of the bus, and that's solved. But anyway, so, we seem to think, because there is this economic, social, structural model of the US that says you have to be alone with your car. I mean, because they still think of themselves as a ride on a horse. And you can have a horse with other 30 people, but it's called a bus. And if there are more, schedule is more expanded, that would be possible to solve the problem. But I would love anyway. Then there was a question here, and then one there.
Good morning, I'm Christine, I'm from South Africa. I really enjoyed the end where you said our compatibility. If you think we are compatible due to the rules that machines have and that humans don't. And I wanted to just add to that by saying, as long as the rules of machine learning or computing suits us, then we are all fine with it. But the minute that it touches you personally, then we don't like the rules anymore. And I was thinking of a simple thing like your password for whatever application you are using. So you think the password is a good thing because it keeps someone else out, but the minute that you forget your password, we feel sort of angry at the program for not letting us in because it is us, it is our environment, but then we can't get in because of the rule of the password. And another example I wanted to share was that being tourists in L'Aquila, we would make use of Google to point us to the path, and more often than not, it wasn't the best one. The first path took us underneath a bridge, sort of not very touristy, so we were like, what is this with Aquila? We see building sites, and then we realized that if we choose another route, it's more picturesque, it's the beautiful one. So while Google chose for us, it was not the best option.
Yeah, exactly.
And for us to sort of, we could have inserted, or we could have asked Google to say, it must be a picturesque, we are two ladies alone. We could have done that, but we were just trusting that, okay, it's going to take us there. And then in the end, it was not.
Yeah.
We had to have the human input, asking a shop assistant, asking someone else, asking to get to the best route. So I just think it is a wonderful idea to talk about the compatibility and the fact that these strict rules versus the human element. So thank you.
Sure. Thanks a lot for this. It was a nice example. So let's have a walk instead. I think there were two more questions there. Next time coming to South Africa, I would just put Google in the garbage and ask people.
All right, yeah, I'm Ari from Finland. Actually related on that, because the reason for not getting exactly what you wanted, you did what is the human thing, to be lazy and just ask, get me here, there, and just done, let's go. And you said about the creativity, and this is, as a teacher, what I'm worried most. Okay. Because my students are outsourcing thinking and learning for ChatGPT. So I'm not giving their tasks because I'm interested them to return me written tasks. I'm giving them for their thinking to go to next level. But if they fucking outsource that to someone else, and it doesn't matter, is it human or ChatGPT? When they outsource, the next generation will be dumber than us. Because we had to work hard to get the next level, and if they push the hard working to someone else, their brain doesn't develop. Yeah. But this is something that, if you have any hints for me, how do I stop them outsourcing? Please tell.
I wish. I wish to. No, there is a. I have one of my students is there in the next question, but I have two considerations on this. The first is this: when you outsourcing the duty, what are you doing? So, what I'm interested in, there is a famous song from an Italian author that asks, you that sell alcohol, well, it's not very educational, but that's anyway. You can sell alcohol, what you buy better than this? That is, once you outsource your intellectual job, what are you doing in the meantime? What is your best option? That is something that impresses me, that touches me. Because if your best options is, looking at reels on kickball, what's the name of the new social TikTok or so like? Yeah, exactly. So you outsource the job and then you freeze your brain for the time. That's something that I would say no way. If you outsource, you do something else, which is, reasonably fine. And then you start putting under the lens what the ChatGPT has said. That is, challenge yourself. Can you beat ChatGPT? Then there will be an interesting use. I mean, I sometimes use ChatGPT as the first referee. That is, I write a sketch of a paper. Then I put it on ChatGPT, say, what do you think? Then I get back comments. I can see immediate contradiction and stupid stuff and garbage, etc., etc. But then I can find out one nice idea, perhaps, or sort of a glimpse. Say, okay, I keep going. Then, I think it's fine. At least I excuse myself enough. Exactly, as a boost.
But when the students use it, it's like they outsource everything.
Exactly.
Which does the worst possible thing for them, because if they actually get the diploma still,
Exactly.
graduate, they go to jobs, and what they can do?
Yeah. No. Exactly.
That's like anyone can do that. Everyone thinks these students
I mean,
based on.
the point is, a car is a very nice means to get faster and safer where you want to go. So I don't say you have to walk everywhere. But once you're moved to the car, you have to explore. So just expand your exploration, not just solve the fact that you have to go there. Daniele.
Can you hear me?
Yeah.
If in the future we were to design a super intelligence machine that were we able to explain the function of our mind, will be able to solve the physical problem of the zombies? Will we remain trapped in a dualistic Cartesian mind-body dilemma, or in a physically made up of electromagnetic impulses?
Okay, Daniele, we should talk a lot about that. You are firing with a gigantic cannon against me. I'm teaching philosophy of mind to Daniele and other 30 guys or something. It's very interesting. I mean, I don't think they will have a better solution than us. It's more or less 3,000 years that we're struggling with that problem, and we haven't come out with a good solution, so I don't think they will do. But we'll see. We'll talk about that when we walk up and back to class. Okay, any more questions? Do you offer a coffee? The university offer us a coffee? No coffee. Damn. Over? Thank you. Thank you, everyone. Thank you for
Excuse me, do you have any certificate to be completed and signed by our side, except the ones you already gave to my colleague? Thank you. Some of you have a template for the attendance certificate to be completed, even if tomorrow we will give our certificates as well. Okay, thank you.
Can we start? Hi, I'm introducing Professor Rita Del Pinto. She is a professor at our Life, Health and Environmental Sciences and in the unit of Internal Medicine and Nephrology. ESC Excellence Center for Hypertension and Cardiovascular Prevention at the San Salvatore Hospital.
Thank you. And thank you for the invitation of being part of this event. I'm sitting here for, it is more convenient for me. I hope you can hear and see. Okay. As anticipated, I am a medical doctor and I am also a researcher in the medical field. So I am used to work on real patient data, on real actual people. So why should I be interested in medical research on synthetic data, and how can we use this kind of data and which implications it has for medical research? Let's go through some definitions first. The European Union defines synthetic data as some data that are originated from a real model, from original data, using a model that is trained to reproduce some characteristics and the same structure of the original data, so it can convey the same statistical information as the original data. Another operative working definition that I really found interesting is the one from the Alan Turing Institute of the Royal Society, where they shift the focus of the definition from mirroring the statistical properties of data to the functional aspects, and so the use for a purpose, for an aim, which is actually using the original data to solve some problems which are otherwise a challenge that cannot be solved. So it becomes a different perspective on how we approach synthetic data use. So why should we use synthetic data in medical field and in research specifically? There are several reasons for this. And we'll go through them in the next slides. Overall, we resort to synthetic data because we want to overcome some real challenges, like, for instance, problems that will prevent patients to achieve some health benefits, like, for instance, through diagnostic processes, through new medications, new technologies. So who works in the medical field knows that there are some diseases which are particularly rare. So the scarcity of data prevents sometimes the possibility to achieve meaningful results through clinical trials. Or there are no treatment options, so people doesn't want to be part of a trial because they do not want to risk being those who receive the placebo or the non-standard treatment. Other issues deal with the length of studies, because sometimes before we can achieve a minimum amount of observation, we require very long time of study procedures, timelines. So another scenario is the one that deals with health policies. So having the possibility to explore some possible strategies in an imaginary setting, so in a setting that is different from the real one, but that represents really well what could be a real scenario. Other issues with real clinical research are, for instance, the need for testing some new tools, new technologies, or hazardous scenarios. So we don't want to put people's life at risk. We want to be confident in our results, but without risking the safety of anyone. Other issues deal with patient privacy, which is something that we know better and better nowadays. So synthetic data are actually data without any personal information of the original patients, so they can protect their privacy. If we conduct study based on synthetic data, we also reduce the costs, which is another very important thing for medical research nowadays. And also we can combine different kinds of data, different types of data, from images to videos to words to text, to create a multi-level learning environment which allows to derive very fine and detailed outputs that can be helpful in the diagnostic process, for instance. And another application is also for the administrative process, for example, in a hospital, and also to understand how to better allocate resources and to optimize costs. Here comes into play artificial intelligence and deep learning, because we generate artificial data through an artificial intelligence trained model, starting from actual data, from real-world data, using the so-called deep learning process, which is something different than in the definition of the different aspects of artificial intelligence. Basically, what we are doing is to use artificial intelligence to look at the real data, to detect patterns, to recognize structures and the correlations that we have in the real data, and then, learning from these relations, generate new data with the same patterns. So machine learning and the deep learning specifically are the key to this process, because they enable us to put together all the information and learn how to classify, to recognize the key elements that will be the focus for the generation of new and synthetic data, allowing generative artificial intelligence to produce the data that we are going to use. And so the topic is so cutting edge, actually, because everybody knows that very recently the Nobel Prize for Physics was actually given to the persons who provided the most important contribution to machine learning and neural networks, which are the kind of network and the technological basis on which generative artificial intelligence stands to generate synthetic data. So the focus, the contribution provided by deep learning is its ability to construct on the, multiple layers of data that we have in real life a meaning. So this tool can generate new knowledge and specifically learn how to make new prediction and classify the data from the information that it gets. Then generative artificial intelligence is able to produce new data from these bases. So in the example of a picture, for instance, where we see different examples of the same item, let's think of a picture with a cat, artificial intelligence will be able to generate a new picture with a new cat, which is none of the cats in the previous pictures, but a standalone new entity, which has the same content and the same information, but is something different and unrelated. Generative artificial intelligence is used to generate synthetic data through different methodologies. For instance, we generative adversarial networks, which means we have two different operators, the generator and the discriminator. The generator is the part of the process which produces new data, and the discriminator is challenged with this new data and needs to understand if the data is real or fake. And the other commonly used method is the variational autoencoders method, where the original data is used to produce a compressed structure, which is decoded somehow, and after this process, new data is generated. Other new and emerging methods are more patient-centric, which means that they want to push the boundaries of data protection to a higher level of security. And they do this by emphasizing the identification of data, by creating like an avatar data for an avatar individual for each individual. So a representation which is anonymized, which is de-identified, and protects the privacy of the individual just to retain the critical information which is useful for subsequent uses. And in this example, the authors actually provide an effective example of how this can be done, and compared to the previously explained techniques, also this methodology is very effective in protecting patient privacy while also retaining the critical information. There are also many open source methods for synthetic data generation in medicine. Many of those methods come from statistical softwares that you might obviously know. In this paper, the authors focused also on why researchers around the world might want to use synthetic data generation for medical purposes. And as you can see here, the main reasons are some of those that we already went through, specifically the problems that we face when we do medical research, reducing costs, enhance predictive powers of predictions of our models, being able to deliver messages that are applicable also to populations that are usually underrepresented in clinical trials, and also enable other researchers to get access to data that otherwise would be only used by some researchers. So make science more accessible and transparent. Deep learning, we anticipated that it has a very specific way and is very crucial in generative artificial intelligence, in the sense that it relies on a powerful capability, which is to handle huge amount of data and very complex data and perform all the analysis on this data in the same step. So putting together the steps that by traditional machine learning are separate. So feature extractions and classifications are made at the same time by machine learning. So the machine is then able to provide an output after a complex identification of the crucial features of data. And it does so through different networks of technologies, so like a real brain would do. We can use synthetic data both combined with real data or just synthetic data as it is, so fully synthetic without any other data from the real patients. Using synthetic data, which are fully synthetic, is usually done when data are very scarce. So we really need to expand our original information because we would not be able to gain insights, meaningful insights from it. Or we use partially synthetic data if something from the original data is to be retained or can be retained because it doesn't put at risk patients' privacy. So, for instance, partially synthetic data are used in health surveys, and authors in this example provide us with the proof that we are able to to allow for effective analysis by using data that are integrated with synthetic information. For other applications that are actually done in medical research with synthetic data, we can synthesize the global use with the following applications. First of all, they can be used to estimate the benefits of healthcare policies and screening policies, as well as potential treatments or clinical interventions, so that we can anticipate the benefit for the final users, which are actually the population. We can use machine learning algorithms and synthetic data to classify information, so to improve the diagnostic abilities of the tools that we currently have to make diagnosis. We can also simulate scenarios and predict outcomes before implementing in the real world the same policies. So by the use of the so-called digital twins. We can boost precision medicine because we can use information from other sources and apply these to the groups of patients which are usually not well represented in clinical trials. We can use it in public health models to predict, for instance, disease outbreaks, and we have, we know what it means because we just had the experience of SARS-CoV-2 and COVID-19 infection, and so we can understand very well what it means to design models for the protection of the population. And another application is the patient-centeredness approach to research and to clinical medicine. So for training purposes of physicians and for applications of research, as we already examined. Let's go through some examples now. For instance, how synthetic data are used to test healthcare policies. In this example, the authors merged together data from different healthcare systems in Australia, integrating them also resorting to imputation methods. From this real data, they were able to extract a synthetic data set that was then used for the prediction of these different scenarios in the setting of health service under demographic aging. So the authors were able to use the synthesized data set to evaluate the impact of different healthcare policies on health service outcome. They presented the scenarios both as optimistic and pessimistic outcomes. So the final users could see what could be actually the implication for the healthcare policy in the future, in the best and the worst scenario. So in this example, the synthetic data used represents an approach to allow policymakers to make the decisions, also in terms of resources allocation, to balance and to make a cost-effective decision on how to use resources. Another application is for disease detection, for diagnosis. We anticipated that some challenges might derive from the scarcity of data in some specific settings, or the need to put together different information which might be different to achieve, or also in some settings like mental health issues, where privacy of patients is a crucial feature. In this example, this was a study focused on mental health disorders, and the authors started from real data on patients with mental illnesses. Using patients' discharge reports, they extracted some specific features related to diseases. They combined information with diagnostic codes and critical information like demographics, and using artificial data to train the model, artificial data extracted from the artificial paragraphs that we were able to extract from the real discharge reports, they proved that it is possible to correctly classify diagnosis in this kind of disease, and patients' privacy could be preserved. So it allows, for instance, research use and at the same time also the protection of patients' privacy. So this is specifically important for patients' privacy protection and also relevant information in terms of clinical data. Another application is for the detection of diseases when we want to rely on the contribution of imaging. This example, for instance, refers to the use of CT scans to classify COVID-19 patients compared to people with different diseases, pneumonia patients or healthy individuals. The purpose of authors in this case was also to provide a frame for healthcare workers to be protected while they are doing their job, so protected against infectious disease, and so for their risk of getting ill while they are working. So this can be another application of synthetic data use for this purpose. And the authors actually demonstrated that using synthetic data set in this context was able to improve the accuracy of detection of COVID-19 as compared to different diseases. So this can be also another example of how to use data which can be sparse, because it can also be the case that the radiologist doesn't have enough experience on a disease, which was exactly the case with COVID-19 at this first outbreak. So it was a possibility to at least recognize a different entity as compared to something that we know better and we have more experience about. In this quote, we can, find actually a foundation of what, as clinicians and doctors and researchers in the medical field, we usually are faced with the need to always rely on the evidence. So evidence-based medicine, but also evidence-based research, and data should be transparent, and all that we, that we show must rely on data. So that's why also synthetic data can come into play, because they can also allow the conduction of clinical trials and accelerate research conduct if they are used to generate synthetic cohorts, and so expand the context where clinical trials can be conducted. This is the case especially for the rare diseases, as I already anticipated, because a few people can be available in a specific area, and meaningful results otherwise could not be obtained. Or we want to expand the control part of the trial. So we want to have a cohort to test, even an historic cohort to expand. So this can be one application of synthetic data when they are used as a way to generate new patients and new information as a comparison. In this other example of how synthetic data can be used to accelerate research and improve outcomes, the authors implemented a generative model to generate histology images. It was the case of hematologic cancer, which is a rare condition and can have a poor prognosis. So it is important that we are able to make timely diagnosis and can effectively examine information that we get from different sources. In this case, the authors analyzed histology images that were synthetically generated, examined the patterns of the image, and combined the information with the clinical information and the genomic information of patients when available. Altogether, these data were put in predictive models, and the addition of the artificially generated images improved the predictive power of models. So it was effective in helping diagnosis of the disease. So this is a real example where the implementation of synthetic data allows increasing the scientific use and the value of the real data just for a very relevant purpose. So accelerating precision medicine and allowing a person to receive the right treatment in a timely fashion. Digital twins are another application of machine learning, of artificial intelligence in research, and this is something that we might know from different and diverse settings. We know that digital twins are representations of an object with the aim of helping in the overall decision making. And the crucial features of digital twins are their ability to analyze and predict in the context where they are applied. So they are based on the actual physical entity, the virtual replica, and the connection between the two that allows for the analysis and prediction of the outcomes of interest. And as you can see here, there has been a rise in the use of digital twins also in healthcare, where they are being applied for the most diverse purposes like decision making, precision care, therapy and treatment, personalized well-being, hospital management and organization, as well as facility design and workflow development. There are some features of digital twins which have to be very individualized, interconnected, interactive with their physical entity, informative and impactful, so the so-called 5 eyes of digital twins. And the connection ideally should occur at different levels and also in along a time frame which ideally comes from birth to death of person and processes. So the main application of digital twins span different areas, just because the final aim is to improve how we offer healthcare services to the individual for the improvement of human life eventually. The different applications span, for instance, specific target pathologies, or as we said, how hospitals can be organized. And an interesting application is also in drug discovery and production. So digital twins are used for accelerating this process, for identifying which can be the targets of new therapies and how the process can be accelerated, can be speed up to get to have new options for treating, especially those diseases which are now without any specific definite cure. So they are used in this setting to mimic potential biochemical reactions and study potential pathways as drug targets to enhance drug development and benefit the humankind. In this context, there are some unresolved issues, for instance, in the way the dynamic changes that occur during a disease can be actually used and targeted for drug discovery. And in this example, the authors elaborated a framework where the digital twin was able to learn from the dynamic changes actually occurring in the real system, in the real biological system. So they prove that it is possible to exploit also dynamic entities and ever-changing human condition and its translation as a synthetic entity for biomarker and drugs discovery. So in keeping with what we just said regarding the importance of relying on data, also in clinical trial design, digital twins can be applied. Clinical trials, we all know, are very expensive and time-consuming processes, and when patients are involved in clinical trials, thank you. It is difficult also to have patients who agree to participate because they can risk receiving no treatment, or because they can get no standard therapies. So the risk with usual research is that we do not reach the power for the study. So here comes into play also the digital twin for in silico trials, and the authors here demonstrate that it is possible to apply this kind of technology also to optimize reaching the adequate numbers to prove the clinical question, and then being able to answer the clinical question. In this example, the authors provide the application of in silico clinical trial for an orphan disease of the pediatric patients. They start from information combining human disease and murine information on how on the biological processes behind the disease and how to treat the disease. So they make a simulation on individuals receiving and not receiving a specific treatment, and they are able to prove that treatment is actually effective for those who receive the actual treatment, but they are also able to classify patients as responders and non-responders or partial responders, and so to be able to predict which clinical features of responders or non-responders we have, so that we can anticipate people who will benefit or non-benefit from treatment. So this can be very useful before we before we start a treatment for a patient, treatment that can be that can also have some adverse events. And in this other study, the authors provide an example of how we can simulate also an imaging trial, so we can compare how different technology perform in terms of providing an accurate diagnosis of a disease. And using virtual images, the authors prove that the new technology, which was not yet in place when the study was conducted, was effective and even could be even superior to the other as compared to the traditional technology for making the diagnosis. So it is important to have this kind of insight, because sometimes the process of regulatory approval for some new technologies or even new imaging technologies can be so long that it prevents patients from getting the benefits of accessing these new technologies. So in these examples, the use of digital twins was able to overcome some pragmatic issues in the trial's conduction and to allow the implementation of diagnostic and therapeutic solutions. It is also possible to use digital twins for surgery and cardiology, in orthopedics. So we are able to use sophisticated immersive techniques that give the possibility to the physician not only to train themselves during medical school, but also apply this implementation to for the benefit of patients. So like planning the surgical procedure before putting it into place, anticipating pitfalls, anticipating problems before acting on the real patients, which is something that is very important, especially for very delicate surgery like cardio, neuro surgery and orthopedic surgery as well. Another application is in how the hospital can be organized, and different operations within the hospital can be improved by using artificial intelligence. So speeding up processes and simulate scenarios like changes in patients' volume, availability of resources, so giving the possibility to administrators to allocate resources in a more smarter way. And also thinking of the hospitals of the future, we also can envision the condition where hospitals are digitalized and can communicate with devices, wearable devices, sensor networks, to allow communication with devices that can provide information directly without that even patients need to refer to doctors, so that doctors themselves can be available at the right place, the right time where they are needed, knowing with the knowledge of what the patient has in his history and what the clinical problem can be. So just to improve what we can get from the traditional and in parallel to the traditional approach to medicine. So I know that it's time to wrap it up. So there are some advantages in the use of synthetic data in medicine, which are in the frame of a patient-centered approach. We can synthesize the advantages in the possibility to boost precision medicine by the integration of data, by using data that are scalable, protect privacy, allow cost-effective medicine and research, allow testing of models before their implementation, and in theory can also ensure equity of access to resources. But we still need to understand that the use of synthetic data can come with some challenges, which are actually more than one. Let's start with the quality of data itself. We start from real data, so the quality of real data is crucial for the quality of the synthetic data. There can be interoperability issues and differences in how the different technologies can operate to generate new data. So are the new data really comparable? Are they standardized somehow? Is the information reliable? The information that comes from different sources. And the issue of privacy and encryption, are they really safe? So are we sure that there is not going to be any breach in the data protection while the process is going on? And also, the equity principle is paralleled by the possibility of actually making greater the digital divide, because there will be some people who will live in some areas, they will be advantaged by the use of synthetic data, but some other countries will not. So we risk emphasizing more and more the difference in how people can access healthcare and the privilege of being cured. And also there are some issues with the acceptability of the technology, because the final users might think of the new technology as something, with some skepticism, and so they might not want to trust the output of research, even though it is rigorous. So there are some relevant problems still with the use of artificial intelligence and synthetic data in medicine. So we can try to figure out how to navigate through these issues, and probably an integrated approach is needed. Integrated approach which requires a joint effort from the regulatory agencies and the users, both in terms of scientific community and final users like patients, in order to be really patient-centered when we plan and realize our research. Education and knowledge should be better presented to even the lay public, so that we can open a debate and try to get insight from patients, organizations, and stakeholders, so that we can put together all the perspectives and learn how to really build a digital chain of custody that is really able to be transparent, fair, secure, and protects information, while also allowing us to use the data that we can actually take advantage from, because in the end, the data-driven decision making is something very, very useful in the end, and we just need to understand deeply that the data is just a part of the information, and the other part, the knowledge and the decision that will be taken are to us. So we are the final users, so nothing can take the place of our brains. And so I thank you for your attention. And
Thanks for this interesting explanation. Do you have any questions for her? Okay, it was very, very strong report. Okay, but now we can have a little break. We can just go out half an hour. At 11:30 we will be here again.
Good morning again, everyone. I'm glad to introduce our next speaker, Dr. Rocco Matricciani, who is our database applications and network area manager, and he's also in charge of the digital transformation at the University of L'Aquila. So I now leave the floor to Dr. Matricciani with his talk, From Data to Decisions, Leveraging AI in University Operations. Thank you.
Good morning and welcome to University of L'Aquila. In this presentation, we'll try to examine how AI streamline university operations. Can you hear me? Okay, it's fine. Concerning the title, From Data to Decisions, it's not my fault. I'm obliged to inform you that the title has been chosen by ChatGPT. Don't blame me. so, okay, it's a joke. Okay, feel free to ask any question and to stop me if you need, if you can't understand or don't hear what I'm saying. Now I will sit at the desk because I need to consult my notes because my English is not my best language. So, okay, thank you. Let's start. Okay, you can hear? Okay, so let's start with a brief introduction to AI technologies. This slide provides a visual breakdown of the key concept behind artificial intelligence. We define artificial intelligence, the general term, as the ability of a machine to show human ability like, to mimic human ability in reasoning, learning, and creativity. While machine learning, it's a set of algorithms that make intelligent machines capable of improving with time and experience. So machine learning refers to systems that adapt and optimize as we give them more data. The more data and more computing power let these machines learn from in time during this training phase. To make an example, when you see the recommendation systems in Netflix or Spotify, that is machine learning. That is the system can suggest you movies, series, music, because they have been trained from your behaviors. So they know what you like, and they suggest you just this music or movies and so on. Instead, deep learning is a specialized form of machine learning. It's more complex network, and it allows more advanced problem solving, such as image recognition. Okay, so the image recognition is that we use in Facebook when we tag our friends, or when we tag photos on our smartphones. And finally, the subset of deep learning, it's generative AI that is built on models, on deep learning models, but focuses on different tasks, completely different tasks, and especially in creating new content, text, images, or audio, as you know. This is ChatGPT or Gemini or Claude. These are the system we know as large language models. So this is machine learning. How does it work? It works in the simplest way of getting the machine to learn, to be able to learn something, is what is called supervised learning. We show the model, a computer, how to learn. We give the computer some examples, in this case, pictures of cats and dogs. These are labeled pictures. So this is supervised learning. We are teaching, training the system with a lot of data to recognize these pictures. And this is something you do very often. Every time you go on the social media and you upload a picture of some friends and you tag, this is my friend, this is my friend. So this is machine learning, and it's based on the same model. This technology works very well, and it works with neural networks. That is a technology that works on data, on high quality data, especially. The more data you give it, the more computing power, and the more the system is able to give exact output. Okay. So, what happened in the recent years? Machine learning was working very well as a technology, but in 2017, there was a research paper from 7 people from working in Google Brain, one of the Google research labs, and that introduced a particular form of network architecture called the transformer. And there was, at that time, one company called OpenAI that started to release a system called GPT. Then, this is the acronym for Generative Pre-trained Transformer. Until in 2020, they released GPT-3. That system was dramatically better than the system that had gone before, because it had 175 billion parameters. To give you an idea, the human brain has only 83 billion parameters. So they are not comparable in terms of complexity, but it gives you an idea of the general complexity. So the problem at that time was, if you have such a huge neural network and you have to train it, you need a lot of data, huge amount of data. And so the problem was, where did I take that data? They decide to use the internet data to scrape website, to use books and other source of plain English text to train that system. And they spent billions of dollars and years of computing to build a very powerful autocomplete system that is, given this prompt, what should come next? What's the next probable word? This model was able only to do this task, autocomplete. And this is ChatGPT. It is a powerful autocomplete system. So ChatGPT is a form of artificial intelligence and an AI which can process and produce natural language and which is capable of a large range of text-based tasks. So it is important to remember that ChatGPT does not itself understand the meaning of what of the text it produces. Its responses are based on probability and statistics. So, what is the next probable word? ChatGPT can only guess this and doesn't at all understand what we are saying. It has some characteristics that makes him allow him to understand the context. The mechanism of self-attention that allows the transformer to see the relations between words in a text, also if it's a big text. Biases, usually the training consists of a pre-training phase in which the model is exposed to data, large amounts of data, as we have seen from different sources, books, websites, scraped web pages, and so on. And so the model learns the structure and the patterns that are in that data, in that training data. So during the training phase, the model is exposed to bias. The bias, it's due to the predominance, maybe, of the North American culture or reflect toxic content, such as hate speech, or violence, misogyny, and so on. So to overcome this problem, a second learning phase called fine-tuning exposed the model to tailored data. And they use this data to make the model more useful in conversation, to make model improve the safety and more ethical, because otherwise it will produce unacceptable outputs. In this phase, also human AI trainers are involved. The major companies like OpenAI and Google Anthropic use guardrails to prevent unusual behaviors. They use these guardrails are applied before the prompt of the user to control what the user is entering, and after, to the output, to control if the content is safe. Otherwise, these guardrails apply. So we figure out that the ChatGPT is not completely reliable and doesn't always know what is true. So it's important for our jobs to, when we use this model, to double check their outputs, to see if there are some true fact or not. This is a scorecard as an infographic. It was released on 12th of September 2024, and it's the infographic that describes the assessment that OpenAI made to the last, the brand new model, ChatGPT GPT 01. It was released in September. And they assess the different areas of evaluation. First of all, they assess the disallowed content. They assess if the model offers response to harmful content, including hate speech, criminal guidance, and so on. The second area is the training data regurgitation. So this is, it checks whether the model repeats or output exact phrase or large blocks of text, both from the training data or the user prompt, data contained in the user prompt. The user prompt is the text you write every time when you use ChatGPT or similar. So that's called user prompt. And the large language model doesn't understand the real context. And this data can be regurgitated without control and can contain also sensitive info like personal data, medical data, copyright, entire piece of books, music, and so on. Although high-quality models now avoid this and generate more unique contextual algorithm responses, this is a risk we need to be aware when we use large language models. So you are advised not to enter any confidential data, personal data, data that can compromise your security. And this reiterates the fact that it is necessary to govern AI. It is necessary to define a policy, ensure that these activities are prohibited at work, not using ChatGPT, but using data, personal data, or that data that can be sensible and use it on LLMs. If users are aware and trained on the risks, we can use all these tools with peace of mind. The other big problem in AI is hallucinations. Hallucinations refers to the instances where AI generates incorrect information. This isn't supported by its training data. In simple terms, when there is a training phase, if there is an argument that the machine can read because it's not represented, then that when we ask something about that argument, the large language model will tend to invent the answer, and it invents very well because it's extremely credible and convincing because it uses fluent language and because it uses concepts that are extremely credible, or at least in statistical terms, the best words that you can generate. So this is another major downside to using these tools. And the bias, we have seen the biases and risks that can occur. These biases are the prejudice and distortions. They are based on race, gender, other sensitive factors. So it is important to understand that bias is not only doesn't always carry a negative implication deriving from the quality of training data. It can also be related to the idea of representativeness. You know, bias can occur simply by failing to consider various cultures, languages, peoples, or nations. So if my country is not represented because my country doesn't contribute to produce training data, I will not exist. This is exactly the bias of underrepresentativeness. Okay, so this is a big problem also. So remember this concept. We have seen the fine-tuning, that is a phase in which the model is in some way corrected. The application of guardrails, because we have to govern the models. The model can contain a lot of bad things inside. But we must understand that even if these techniques are making remarkable evolutions, the heavy part continues to live there in the deep neural network. During training, the model builds these connections based on the data, and no one, also who planned this system, knows exactly how it works, because since learning process is spread across millions or billions of parameters, so there is no way to get rid of it. We don't know how the billions of connections were formed. We can just turn off a part. It's like the human brain. You cannot cut off a part of it and eliminate specific bad thoughts or behaviors without serious consequences. So, the question is, can we trust generative AI? Here, it's a couple, we give a couple of examples. Sorry. Okay, this is the Chihuahua or muffin problem. It's a classical problem in AI, and the model struggle to recognize, to distinguish between objects that are conceptually similar. In this case, we have a Chihuahua, that's a small dog breed, and muffin, that's baked good. And as you can see in the central row, there is the answer given by ChatGPT. It says 9. There are 9 Chihuahuas. And also Claude, that's another AI, another large language model, that say 9. So they both were didn't give any correct answer. That's because they are very similar, no? Conceptually. It has 3 eyes, so the model is not able to distinguish them. Another example is in math calculation. You see, if I give the model a number with 5 digits, it's not able to make a multiplication. They are both wrong. They both give a broken result. This is also important to know. This model can fail in doing calculations or image recognition. So now I would like to make a little survey, just a question. How many of you have tried ChatGPT, Gemini, or Claude during at least one? At least once. Okay. So let's say 50%? No, 40%. The next question is, how many of you have used ChatGPT, Gemini, or Claude to do work tests, office tests? Work tests, office tests, job, office, only 3 or 4, okay. So 10%, let's say, lower. And next question. How many of you have used ChatGPT to do important office jobs without telling this to your boss, friends, colleagues, or customers? Okay, only one. So 1%. No, it's about 2%, okay? So, well, according to the result of this survey, 2024 Work Trend Index annual report from Microsoft and LinkedIn, at least 75% of people is already using AI at work, and 50% of them are reluctant to admit using it for their most important tasks. So maybe this survey is wrong or that you are lying. I don't know. Okay, I'm joking. But the spoiler is that AI is already in our workplace. We missed the opportunity to regulate it with policy. So if we think that we can govern the AI by deciding when it would be time to start using artificial intelligence, we have lost, because AI is already entered in our organization. So this is important. We have to govern it, we have to make a policy. Another question. Do your organization have a policy on AI? Someone knows this? No? No one. Okay. And have you received training or education on AI? At all? Okay. Okay, don't worry. It's like here in L'Aquila. It's the same. But because we are waiting that something happen from the outside. Maybe we are waiting the effects of AI Act or other governative choices. So we will see that it's not this situation in other countries, in other part of the world, are completely different, okay? Oh, this is just a slide with the most important large language models. Okay, say GPT-4, it's the most well-known. Claude, Mistral, Gemini, the large language models on the left are the most used. Each of them has specific recommendations. For example, for general purpose, you can use ChatGPT-4. For Claude is better for programmers, or maybe because it's more ethical than other large language models. Gemini is more fast and more integrated with Google, so it's better for integration with the web to make web searches. But I leave you the slides so you can see you later. Okay, this is, please. Yeah. I will leave the slide. Okay, in the slide there are also some links. If you click on the images, you go to the external resources. Here there is a link. This is a page where it's a showcase of AI policies in the world, in the global educational sector. If I click on the image, can you see it? Okay. Can you see it? Okay. So here we have the non-EU university policy on AI. This is a Padlet, it's a showcase of all the policy. These policies are from American University page. You can see how many of them. It's an impressive amount of policies from American policies and research about AI. Okay. The same thing, I struggled a bit to find European university policies on AI, but now there are quite a lot, but it's not very common. And in Italy, only 4 universities are using, decide to have a policy. So the situation is very different. And here we can see this link, you can use it, this page, and also add some resources if you want. You can use freely. It's like it's a repository of resources about AI and education, university in general. We have a resource like this from UNESCO. This is a survey that say that less than 10% of schools and universities have formal guidance on AI. So they say this thing, it was from 1st of January 2023, but it's extremely actual, I will say. After we can see some university, for example, University of Michigan. Okay, there are a lot of resources, and also you can see about AI. They give services to the users. They give generative AI, ChatGPT to all their users for free. They are in some way. Look at this. They give also information how to
Maisie is a generative AI
index their
customization tool
documents.
that allows U of M
You can
faculty,
realize
staff, and
with this
students
service
to build their own version of UMGPT that is trained on a custom data set they provide. It can be used
you
to
can
build
load your
course helper
documents
tools or gain
on
a
this
deeper understanding of the data
UMASI
provided.
and use
It only
this
takes a
service
few minutes to build your own custom chat
to
tool
use your
using
document
Maisie's
to
intuitive,
query your documents.
user-friendly, and accessible
It's
interface.
very interesting
After
service.
logging into
And again, you can freely navigate this Padlet. Where is it? Here it is. And discover other services. Okay, so you can click on this page and go to the Padlet. Okay, let's go ahead. This is just we have analyzed the processes we carry on our administration, try to make some domains, main categories: process optimization, document analysis and management, interaction models and multimodal support, and other application. These are all use cases we are analyzed in our organization. Okay. Goes from chatbot to cataloging and indexing of minutes, regulation, decrees, etc. There are many things we can do. We try to put them on this page. Also, this is another use case, higher education, student careers, and then customized learning paths, personal recommendation, feedback, student retention, a lot of things, use case goes into these categories. This is robotic process automation, which it's a technology that permits to automate things inside the administration. How it works? It works performing tasks that would typically require human intervention. So it works performing data entry, and processing transaction, managing email, and reading and interpreting structured or semi-structured information. So, for example, there are usually in the administration work, usually it's about taking information from one software, copying, pasting in another software, reading an email. I take a piece of text, make some search. This is a huge amount of time lost in doing these activities. Robotic process automation can automate all this stuff and can do all the things a human can do on the same interface without modifying the software, the original software. So that's very interesting application. Here we can see some use case from the other universities in Italy. Buongiorno. These screenshots have been taken from various presentations of Italian colleagues. On the left, upper left, you can see some use cases from Università Cattolica in Rome. This is a part, artificial intelligence tutor. It's an AI to support students in preparation of examinations. Other interesting applications are this use case, this test made by University of Torino. The first one is analysis and planning of web pages. This is an AI system that read the pages of other universities, try to learn how they are made, and suggest the best possible adjustment of this page. Give suggestion on how to make new page on the website, on your own website. That's very interesting application. Another test is this on the center. They use this Lumen, this AI that's able to produce videos simply like ChatGPT. You put some description, some text description, and produce video in just few minutes. I will show you what I was able to realize in just 1 minute. I put the text in. Sorry, because there was the presentation in front of it. Okay. Now you should see it. Okay, this is just to give you an idea of this is what my input, only this. I gave 10 rows of text and produced everything. The problem may be you put the American flag and at a certain point, but this is AI, you know. Okay, let's go back. So, another example is the University of Torino analysis of customer satisfaction feeds. They read these forms automatically, and so they have to the automation of this process. It's very useful also. Oh, these are the UniVacu use cases. They are being carried out here at the university mainly during 2024. This activity was carried out following the assignment of a performance target by our General Directorate for Experimentation of AI Solutions in the university. The first use case we implemented was the chatbot. It's an AI conversational chatbot to provide support to users. Our case focused on developing a chatbot to support users for questions relative to careers, administrative staff, and in particular, all the training set consists of the following knowledge base. We have predefined standard answer of the help point, the solution records, frequently asked questions on the university website, and reference document resources like tuition fees, contribution guide, master regulations, and so on. We take all these documents and index them without modifying them. So, the document were the original one, just to see what happened. So we developed the chatbot using only internal human resources. The testing employed dual technology solution, one commercial, the other open source and free. This was made mainly for comparative purposes and also to experiment with open solutions, hopefully to prevent the vendor lock-in. Also, we aim to experiment with various technologies to master them and gain insight into future trends and technological advancement. So we hope to become more and more expert of these technologies. We use a technology called RAG, that is Retrieval Augmented Generation. As we know, the large language models like ChatGPT and the others, they have been trained on generic data taken from internet, Wikipedia, and so on. And however, this large language models doesn't know anything about our specific domain, but our documents. So this can be addressed using RAG, that it works by retrieving the relevant documents from our database, internal knowledge base. That can be a database or documents or whatever. And it's able to generate responses based on the retrieved content. So the ultimate experience it was that this chatbot, it offers fluent, pleasant interaction. The outcome of the internal experimentation demonstrated the validity and accuracy of the answers, and with very satisfactory results, taking into account that the indexed data were extracted from the facts and regulation without any optimization. So To give you an example, the chatbot is able, as you can see, is able to answer in English, even though all knowledge-based documents are in Italian. So we didn't make any optimization. Sometimes gaps, document inconsistencies, communication issues were identified and provide us valuable insights to modify our documentation. Certain specific queries, instances, give us hallucination problems, which are challenging to address with working with the system prompt alone. So these issues can be resolved through predefined solutions. We can, when the RAG doesn't know the answer, usually tends to hallucinate. And so we can, in that case, we can redirect the user to contact the help desk, or we can say that we don't know how to answer. Now we are following an initial experimentation phase. We are involved both technical staff and domain expert. We want to extend the experimentation exclusively by domain expert. So the final decision was, we have decided that the chatbot is not ready for development yet because the answers are not so reliable. And, but we're aiming to repurpose the chatbot with rolling version. So if it's not ready for external user yet, we can have it help our service team. It can help the service team to handling repetitive tasks such as preparing answers. And in this way, we can test it without the risks and contribute to streamline the university operation. So it's, we don't want to lose all the work we have done on the chatbot. Oh, so that's a slide introducing Copilot for Microsoft 365. It's a technology from Microsoft. It expands the application, Word, Excel, PowerPoint, the usual Office applications, and extend their functionalities to AI models and let them access also documents in our tenant. So we can use this application and work on documents in an intelligent manner. Let's see. Our experimentation was on these 5 applications: Word, Teams, Excel, PowerPoint, Outlook, and there was a work group, a special work group of experts in this application who tested their usage for 2 months. This is Teams. Sorry, the screenshots are in Italian, but we use the applications in Italian. So I can represent what is on this slide. On the left part, there are a list of categories that has been identified automatically by Copilot. This is during a meeting. You can have this automatic classification, and you see there are categories and colors that refers to the line bar where you can see the transcript and also listen to audio and video. So it's very useful for navigating a past meeting or during the meeting. So other features are that So list of arguments automatically generated, meeting notes, and at the end of the meeting, a list of activities to be carried out by people. So it may assign activities to people, it analyzes the audio and decide who should do what. It's very useful and powerful. Outlook, same thing. Here, there are various automation features, but most interesting is the research, is the search functionality. It uses semantic search, so you don't have to remember a specific text to do a query. But it can understand the meaning. So if you have to find a document, you don't remember exactly the name or the content, you describe it, and the system tries to answer. It's very, very useful. Excel here also can help unexperienced users to produce graphs, pivot tables, very advanced features that usually unexperienced users cannot use or don't use usually. So that's another useful, very useful application. Another one use case, important use case we made is chat with your data. In this case, we use the Notebook LM. Notebook LM is an AI developed by Google, allows you to process, synthesize, and query documents using a large language model. It helps extract key information from your files and create summaries and answering specific questions. So you can chat with your data. Let's see an example. Allora. That's it. Okay. Okay, this is part of my work. What I've done, I uploaded 2 documents here. Oh, it's flickering. The PIAO, this is a strategic plan, 3-year strategic plan of our university. And this covers a range of topics, public value, performance, anti-corruption, etc. And the PIAO is about 300 pages, so more or less. Then there is the Piano Triennale Informatica. That's about 100 pages, and it's another strategic plan for digital transformation. Okay. So I can chat with my documents. For example, here there are some predefined questions. The suggested questions are okay. What are the key public value objectives that the University of L'Aquila aims to achieve to its strategic and optimization plans, operational plans, sorry. Okay, made the query. So this is the result. So it's a list of key points and the key public values as reflect in strategic operation plans are to enhance education quality. For each of these key points, I can see there are indexed. I can click on the index and show me the content of the document, exact the content. So I can check if the information is correct. I can check the the original document. It's very useful for navigating your own document, or also to compare documents from different administrations, just to see if I'm covering different aspects of that domain. Another interesting thing is, yeah. The article is in Italian also, yeah. So it's able to understand an article in another language and give you a summary, or you can make queries in another language. Now I'm reasoning in English, but the two, if you see, here, see, we will see next. That's nice. Also, you can generate facts. It's useful for putting these facts on a website, for example. Frequently asked questions. Siamo lunghi? Un po' lunghi? Okay. You have the lunch, don't want. Okay, so this is the facts, you know, generated fact, a list of frequently asked questions.
About that document?
About the two documents. All
they intersected the two documents?
Yeah, all the, what I'm doing, it's about two documents. If I upload 10 documents, 50 documents, you can do the same thing. Yes, let's go to the nice part of the audio. Yeah. I can. Okay, let's say the question before.
Yeah. So, what kind of documents are possible for your application? PDFs, images, Microsoft, everything, Excel.
Everything.
Everything.
In this
okay.
case, there are two PDFs. One of 300 pages and the other 100 pages. So you can upload them. It's simple. You look, I can just in this way. I can upload results, choose the file, you put here,
and
you
then
can load.
you prompt. Okay.
So after the documents upload, it's indexed by the large language model, and you can use it after some minutes. In the same way, this is an audio overview. And this is a very choreographic thing. It's, it has generated a podcast that are two people talking to each other about these two documents. It's
hey there,
like
future-minded friend. Ready to step into the University of tomorrow? We're on a mission today, diving deep into the University of L'Aquila's plans for a digital revolution.
Really ambitious stuff.
And we're not just talking about, you know, adding a few more computers or something like that. They've got these detailed blueprints of the integrated activity and organization plan for their big picture vision.
Right.
And then the 3-year plan for digital transition, they get into the actual detail.
Yeah.
Okay, this goes ahead for 26 minutes. It's good. Before going to sleep, this is wonderful. Now, imagine how it's powerful, this technology. If you want to produce multimedia text or a lot of documents, you can put it on as a guide just to learn the boring stuff, you know.
But you expose your data to the web, and
Yeah.
probably it's for free. and that's why you are exposing your data, and it can be used for training large language models, or?
Yes, I'm exposing because they are public documents, so it's not a problem.
Okay, so you have to be careful if you use that. Okay.
I cannot, that's another problem. Today we are not protected from the large language models that reads our documents on internet. Maybe tomorrow when we'll have a planetary police, we can say, okay, my documents remains private, okay? But at the moment, they can take everything from the web. So these documents are public. Yes, you have to be careful to expose private documents also on this model. But we have another model. We have seen before Copilot 365. That's we can do the same things. It's called chat with your data. It's a service, we realized. And but all your data are inside our tenant. That is the same place where all our documents, office documents, are normally. So we have a contract with Microsoft, and these documents will never leave our tenant, and they will never use our documents to train their model. Okay, so if you want to use personal, private, or job document, you have to use different tools, not these Google tools, because Google doesn't give you the policy. The policy is the most important thing, remember.
I have one question regarding this tool as well. We know that because of the data security, we have to pay attention, but do you recommend your students to use Notebook LM?
Do you
currently?
recommend, sorry?
Do you recommend your students currently to use Notebook LM? Or you just use that for university?
You can use for, if you have public documents, you can use freely, it's not a problem. Also, if you have a contract with Google, there is also a commercial use of Google Suite. Many universities have a commercial agreement with Google, but this is a free part of Google. So if you go into Google with your account, you are using a non-commercial service, and the policy is different. So they can use your data. When we talk about training these models, when we talk about training these large language models, where the big companies use your data, use the data you use on Facebook, on the free services, because these services are free because you give them data. You give them the real value is your data. Okay, let's go to the last of our services. Okay, this is what I was saying. We realized this service internally with Office 365, so our documents in this case are protected. This is based on minutes of the board of directors and Senate. You can ask the chatbot when a topic was discussed, who voted against, what were the most discussed points, etc. This gives significant time savings, especially when searching for information. Oh, the last use case is the 4 Smart project. And it's an initiative involving multiple Italian universities aimed at using smart sensor technology to monitor and manage environmental parameters in academic space. So the project collects data such as temperature, humidity, quality, electromagnetic pollution, and integrate them on a cloud platform. So the main goal of the project was to improve student well-being, optimize energy efficiency, improve management. What we have done, a professor, Professor D'Alessandro, together with some students, made an experimentation focused on estimating the classroom occupancy only using indoor air quality sensors, quindi indoor air quality data combined with external meteorological data. So the final result was moderately good. It has an accuracy of 65 to 90%, and the study was completed in July, and we intend to extend the application of these models to all classrooms, because this, for us, for our university, is very strategic to know, to optimize the allocation of classrooms. And also for students' well-being is very important. Okay, so what the outcomes of our AI journey, we can say that the potential of AI in university, it's extremely important. We are confident that there will be a tremendous potential to enhance university operation. It's important to map the processes and start identifying areas of AI applicability, especially for repetitive and low value-added processes that can be easily carried out. So we have seen ethical and privacy consideration. We must be careful when we plan new services. Okay, just a little video, and we can. This is a video from the last ChatGPT 01 advanced voice.
Hey ChatGPT, I'm here with my coworker today. We'd like you to act as our translator for us. So every time I say something in English, can you repeat it back in Spanish? And every time he says something in Spanish, can you repeat it back in English?
Sure, I can do that. Let's get this translation train rolling.
Hey, how's it been going? Have you been up to anything interesting recently?
Hola, ¿cómo te ha ido? ¿Has hecho algo interesante últimamente?
Hola, bien. Sí, un poco ocupado aquí preparando un evento para la semana que viene.
Hey, I've been good. Just a bit busy here preparing for an event next week.
Can you tell me anything about it? That sounds really interesting.
¿Me puedes contar algo sobre eso? Suena realmente interesante.
No puedo decir mucho, pero creo que el resto del mundo lo verá dentro de poco.
I can't say much, but I think the rest of the world will see it soon enough.
Oh, well, I can't wait to see what it is as well.
So, you see, it's very, extremely powerful. You can have it with, it has been released on September together with the 01 model. Now it's available only in the USA. The situation in Europe is quite different because currently it's unavailable, maybe because the OpenAI say that is because of the restriction due to the EU AI Act. So they say the problem was the AI Act. This is quite controversial, and it will be a problem for these companies to bring this advanced product, because the problem with product is that it can recognize emotions, and the AI Act doesn't allow this. So that's a big problem for us. Okay, I finished it. I will be happy to answer other questions.
Thank you, Dr. Matriciani. Any questions? Other questions for Dr. Matriciani? No? Oh, yeah.
I just have an organizational question, really. So thank you very much for your presentation. It's been very informative, I would say. And so the question to the professor is, can you please let your presentation available for us, make it available for us, because it's a lot useful. And then the continuation extension to the organizers. And what about the other presentations? Can we also get them? Yeah, so that will be very useful for all of us. Thank you so much.
Sure, thank you. Thank you, everyone. And I wish you a good continuation, good staying here in L'Aquila.
Okay, so just before you leave, you have your lunch break now, and we will meet back again here where you met the guide, Andrea, yesterday, at 2:15, 2:20, okay? And one thing about tonight, for those of you who are going to the dinner, the meeting point is here outside our building at 7:15, no, 7:40, 7:45 tonight, okay? And in the afternoon, 2:15 for the guided tour, the second guided tour, okay? Thank you.